In this video, I want to show examples of multiplying rational expressions. The procedure for this goes back to the idea of multiplying fractions because rational expressions are just fractions with variables in them, right? So you may remember that we multiply fractions by just multiplying across the numerators and across the denominators. This is about the simplest operation that you can perform with fractions. But there's one key tip that I want to discuss that will be essential when we're multiplying rational expressions. And that's the idea of simplifying our expressions first by dividing out common factors. I want to show you an example with a fraction. So if I'm multiplying 6 over 16 times 20 over 3, I could just multiply across numerators and denominators, right? I would have 120 over 48, and then I have to simplify this by dividing out common factors, so this might take repeated division until I rename this in its lowest terms of 5 over 2, dividing by 24 here. So this is equal to 5 halves. But there's a different way that I could approach this problem. I could take 6 over 16 times 20 over 3, and before the multiplication, I could simplify by dividing out any common factors in any numerator and any denominator. For example, I look at the numerator 6 and the denominator 3. Those are divisible by 3. So I could divide this by 3 and it becomes 1, divide this by 3 and it becomes 2. The numerator 20 and the denominator 16 are also divisible by a common factor of 4. So I divide this by 4 and it becomes 5. I divide this by 4 and it becomes 4. So now what do I have? I have 2 over 4 times 5 over 1. But we're not done even now because the numerator 2 and the denominator 4 are divisible by a common factor. So there was no special reason that I had to divide diagonally like this. I can divide any numerator with any denominator as long as they share a common factor. So divide these by 2 and I get 1 over 2. What's my result? I have 1 half times 5 over 1. Then I just multiply across. 1 times 5 is 5. 2 times 1 is 2. There I have the final answer. There's no simplification required at the end because I've simplified at the beginning of the problem. This is necessary when we're working with rational expressions. So we'll look at some examples now with rational expressions, and we'll simplify first by dividing out common factors, then we'll multiply across numerators and denominators whatever remains. So let's start this example by dividing out any common factors in numerators and denominators. I'll start with the variables just because it's a little easier to start there. I notice an a squared and an a squared. Those are common factors. We'll divide them out. Here I have an x squared and here I have an x. So when I divide out the common factor of x, I take this out and this becomes x to the first. Here I have y cubed. Here I have y squared. When I take out this common factor of y squared, this becomes y to the first. So I'm going to rewrite what I have just to make it more clear. It looks like we have 27 over 16 times 20xy over 9. Now let's divide out common factors in our coefficients. 27 and 9 are divisible by 9. This becomes a 3, this becomes a 1. 20 and 16 are divisible by 4. This becomes a 5, this becomes a 4. So now I have 3 over 4 times 5xy over 1. It looks like we've divided or simplified everything possible, so let's multiply across numerators and denominators to get our final result, which is 15xy over 4. If we're careful to do all the division of common factors before the multiplication, I should not need to simplify this expression at all. It's fully simplified, 15xy over 4. As we look at multiplying more complicated rational expressions, we just remember the strategy is exactly the same. So I divide out common factors and then I multiply. Remember, common factors are terms that are being multiplied together within numerators and denominators. So the x squared here, those are not factors, right? This 3x, that's not a factor. We have to factor these expressions first to discover what factors are included in this expression, and then we can look for our common factors. So let's factor everything. I'm going to also rewrite a couple of these denominators in a more standard form. I have x squared minus 3x plus 2. Let's go ahead and factor that. That factors as x minus 2 times x minus 1. Here I have 9 minus x squared. I'm going to reorder that so that the x squared comes first. And I'm also going to pull out a negative sign so that the x squared is positive. So that can be rewritten in a couple of steps as negative x squared minus 9. Right? So 9 minus x squared is the opposite, or the negative, of x squared minus 9. In the second expression, let's factor this numerator. X squared plus x minus 12 factors as x plus 4, x minus 3. And I'm also going to rewrite this one both by rearranging the terms and then by factoring out a negative sign. So this becomes negative x squared plus 2x minus 8. Now I need to factor both of these denominators. So let's take one more step to factor our denominators and then look for common factors. So the negative of x squared minus 9, this is the difference of squares. So I have x plus 3, x minus 3, and notice the negative sign is still there. That's like multiplying this by negative 1. Here I have x plus 4 over times x minus 3, and in this denominator I have x plus 4 times x minus 2. There's also a negative sign out in front here. All right, so now we've factored everything. Now is the fun part. We can divide common factors, right? X plus 4 and x plus 4, those divide out. Here's an x minus 2, which divides with this x minus 2. Remember, any factor in a numerator and in a denominator can be canceled or divided. It doesn't matter if they're above and below each other or if they're diagonal from each other. Here we can divide an x minus 3 and an x minus 3. So let's collect what remains just by multiplying it all together. In the numerator, I have x minus 1, and there's nothing here, so that's like multiplying by 1. So my entire numerator is just x minus 1. In my denominator, I have a negative sign times x plus 3 times a negative sign. This is like multiplying by negative 1. So when we multiply negative 1 by negative 1, that becomes positive, and the only factor remaining is x plus 3. So those two negatives became a positive sign, which is why it doesn't show up here. Here's our final result, x minus 1 over x plus 3.